For the next question, again, we do have the series part, but this time instead of just having R1 and R2, we are going to have R3. So at this point, 1K, 2.2K, and 3.3K are connected to each other. So our total is going to be addition of all of that. Our total is going to be 6.5K. The only thing we have to do, add them up, right? Then we have to find the total current. I total is going to be V divided by R total. V is 10 volts, and R total, as we know, is 6.5K. Either you can write 6.5K or you can 56500. If you do that, finally you have this number 1.53 milliamp. Then the question asks for the voltage drop over R1, R2, and R3. The only thing you have to do, multiply the current that you found by the resistance. If you do that, the very first voltage is 1.5, second one 3.3, and finally 5.07. If you add all of these up and based on some kind of rounding, finally you should have the KVL right and 10 volts. So let's move to the next question. The next question is somehow similar to this one, but rather than 2.2K, we are going to have another resistor over here, 3.3K. So the only thing you have to do, get a copy and paste, or just use the shortcut that you know. Connected over here, it could be connected over here, we don't need that. So we do have 6.5K, that makes sense. 1K, 2.2K, and 3.3K. Forget about these voltages, it's completely wrong, and it's also damped completely, it's off. So then we have to just get rid of that. Let's connect it backward to the place it was, and then we do have our voltmeter. So we do have the voltage, by the way, it should be 10 volts. The source should be 10 volts. Then it asks for the current, for the total current. So we do have the total current 1.39. We do have 1.38, which is so close. And the voltage of R1, 1.38, that's okay. Voltage of R2 was 3.384. Then let's just copy and paste this. And we are going to measure the voltage of the last resistor. It's going to be using a wire over here, another wire over here. So we do have 5.077. That is completely right. Let's look at the next question. As you can see over here, I just built up the circuit by myself because obviously it takes a little bit of time. So for the next circuit, we do have the 10 volt as the source. We have to adjust this voltage source because it's 12, not 12 anymore. R1 is 1K. We had the 1K over here. R2 is going to be 2.2K. As I told you, we don't have any 2.2, so we are going to improvise and build the 2.2. It means that I do have 2K, 100 ohms, and 100 ohms. Then the question asks to add another series resistance, 3.3K. Since again we don't have the 3.3K, we are going to use 2K, 1K, and 3 100 resistance. So it would be what? It would be 1 2K, 1 1K. 1 to 1 is going to be in series, and as you can see over here, since I didn't have any place or space over here, I would say that okay, why not try to use these rows? And since these rows and these ones are not connected to each other, I use a jumper or wire. So at this point, I connected this side or right leg of my resistance to the another leg or left leg of another resistance. So I do have these 2K, I'm sorry, this 1K, 100, 100, 100. And out of these two, instead of just connected directly to this guy, I use 2 jumpers, which is very common that you do that. So it means that at this point, I can either connect it directly to the source that I would like, or I can just connect it to this wire, to the power rail. As we know, the power rail is there in order to supply your voltage. So I can connect the positive side over here, I can connect the negative side over here, then use another 2 jumpers and directly connect it to that. Since right now it's not necessary, we're not going to do it. So right now we do have everything we need, we do have our circuit. The very first thing you have to measure is about the total resistance. So the total resistance, again, as you can see, we are going to use our multimeter. It's on the 20 ohm settings. On the 20K ohm settings, the maximum is 20K, and I would like to measure the total resistance. I'm going to light it up, connect it over here, and you can see we do have a number. So this number is something around 6.47, 6.5, which is okay because the resistance, since all of them are in series, if you add all of them up, you do have the 6.5K. Then the question asks for the total current. Based on the calculation, I know the total current is going to be what? Is going to be 1.538 milliamp, which is very precise. So the very first thing you have to do, first of all, let's turn it on. let's adjust the source because the question asked for the 10 volts. So I have to adjust it. Let's decrease that guy. 10 volt, yeah, it takes a little bit of time. So it would be 10 volts. Okay, almost 10 volts. So I do have my voltage source. Voltage source is ready. Let's turn it off. And after that, we have to connect the wires or connect the cables that comes out of my voltage source to the circuit itself. So I do have this negative side. This negative is going to be, instead of either I can connect it directly to that one, but I can do it over here. Since I need more space, I'm going to do that. As you can see over here, right now, then the ground side is connected to the whole circuit itself. So what about the positive section? The positive section, we are going to do the same. And like this, everything is settled, so we can leave it as the way it was. So right now, everything is okay. The only thing you have to do is just turn it on. As I told you, right now, we would like to measure the current. Since the current is in series, it means that a current that goes from the beginning through this current, through this guy, through this guy, through this guy, all of them are going to be the same. So it means that we don't have any problem. Since we do have a series circuit, I would like to measure the resistance that gets inside of this guy. It means that right now, instead of just having my connection directly to the positive side, I can get rid of this wire, because right now I don't need it. I can connect it to my current source, which is going to be this guy from the multimeter. Right now, as I told you, the current moves perfectly and directly from this one to my multimeter. And right now I have to connect the negative side, which is going to go over here, this guy, to this point. So right now I can measure my current that goes through that. Since I do have some kind of expectation from the current is something less than 2 milliamp, I can adjust this guy. As you see, I can adjust this guy to around 2 milliamp. Okay, I do have it. So it would be 2 milliamp. So let's do the measurement. First of all, let's open this up. Let's turn it on. I do have a 10 volt, perfect 10 volt. And if I connect this guy to this section, I should have around 1.5. See, I do have 1.578, which is going to have some error, obviously, because of our multimeter is not perfect. We do have some resistance also inside of wires, inside our probes. So it was 1.57 and we do have 1.538, which is still going to be in acceptable range. We don't have any problem with that. So then it asks for the voltages, VR1, VR2, and VR3. The very first thing you have to do, turn this off and connect it back to the normal way that it was. It means that I have to connect my sources. So the negative side is just connected over here as the way it was. The positive could be connected either using a wire that we have to connect it again on the same row. Let's do it, by the way, instead of just making it a little bit messy. Okay, right now it is connected, and then we also have to connect this guy over here. So my circuit is perfect. I don't have any issue. The source is connected. All of the resistors are connected perfectly. The question simply asks for the voltage. The only thing you have to do is just have a multimeter, and then we have to, first of all, it's important to make sure that this guy is going to be in the right range. Since we expect to see something around 2 volts, 3 volts, 6 volts, 10 volts should be fine for me. So I'm going to have, maybe I don't have 10, but 20 volts is okay. So I can read it right now. The very first part is about the VR1. What was the VR1? R1 was 1K itself. This guy is 1K. So the voltage of this guy, I expect to be something around 1.538. Again, try to connect the red side or the positive section to closest to your positive part, because it is the way that current moves through. Turn this on, measure the voltage. We do have 1.55. Let me just turn it on for you. We do have around 1.55, which is acceptable. That is okay. Then it asks for the VR2. VR2 is 2.2K. As you remember, we didn't have any 2.2K, so we have to improvise. It means that I have to connect this one, which is 2K, 100 ohms, and another 100 ohms. Right now, if I would like to measure the voltage, instead of just each of them individually, either I can do that, by the way. I can just connect the voltage for each of them individually, add them up based on the KVL that works. But right now, let's just do the direct way. It means that I have to connect this positive side over here and another side over here. So I expect something around 3.3. Let me light this up. It could be 3.3, 3.4. Yeah, it's a little bit fragile because it's not directly connected. We're touching it, but if we have something we call this alligator or clips, those clips are going to be around your probes, and it would be directly connected to the component you like, and everything would be perfect. Then it asks for the voltage of R3. R3 is 3.3K. It means that we need 2K, 1K, 100, 100, 100. So right now, if I do this measurement from here to the end, I should reach something around 5 volts. See? 5.2. It should be around 5.1, by the way. That is totally fine. Still beyond the margin of the error that we need. So everything worked perfectly. And we found everything that we calculated with the measurements. Then at the end of this some kind of section, we are going to talk about error, that how we can find the error. So don't worry about it. But since still we are at the 5 to 10% error, everything is fine. For another one, we do have this parallel scenario. It means that I do have R1 and R2. They're in parallel, and I do have a 10 volt. So the question simply asks to find the total resistance. We know the total resistance in parallel condition is 1 over RT equals to 1 over R1 plus 1 over R2, or R total is equals to R1 times R2 divided by R1 plus R2. As you guys know, the only time we can do this formula is when we do have only two resistance in parallel. So we do have the R equal is going to be 2.4K. Then the question asks for the I1, the current inside this branch, and the current inside this branch. So I1 would be 10 divided by that 3300, which is going to be 3.03 milliamp, and I2 is going to be V divided by that by 10K is going to be 1 milliamp. If you add them up, your KCL should be right, so your I total is going to be this number. Another way that you can find the I total is just divide V by R total itself. It is 10 volts divided by R total, whatever is that, 2.4K, and you should have the same number. Again, by adding this guy, which is going to be voltage source, I do have it like this. As I just told you, we have to just change the direction to be like that. The voltage should be 10 volts. Then we need a resistor. Obviously, first we need the wire. Click on W, and then we do have the wire over here. After that, it gets hit ESK, and you can hit R, or you can just simply find the resistor on the top, or you can just find it from draw. Hit R, and like this one. Again, use W, connect it like this. Again, use another R. You do have your resistor side by side. Use W as a wire. Remember, try not to connect the wire like this from over here to here, because at this point you do have somehow this connection. At sometimes you see that there's no current goes through that. So it is important to have one wire connected over here to here, then another wire from here to here. Right now you see you do have the current that goes through the middle branch. Then we need the ground. Either you can hit G, or you can just click on this one, draw that, and we do have everything that we need. So the question first asks for the total resistance. Get rid of that one, go to draw, output, then hit the ohm meter, connect it from here to here. Then you do have 500 ohm, because right now it's 1K and 1K, which is not our concern right now, because we need 3.3K. The very first one is 3.3. Don't forget to put K. And another one is 10K. 10K. Okay, hit. We do have 2.5K or 2.482. Just this guy just rounded up. So we do have everything we need. That is totally fine. Get rid of that. Hit delete. Then move to the next part. You have to add the voltage source. 10 volt, 3.3, and 10K. Obviously, the voltage of these two guys are also going to be 10. Both of them are in parallel with this one. That completely makes sense. Then it asks for the current goes inside the total current. Then the current inside this branch and this branch, and after that we have to prove that KCL works. So let's move this guy a little bit more. Then we have draw output. We need ammeter connected from over here, so total current 4.03, just like the question or just like the answer. Just get rid of that like this. Again, either we can copy and paste this one, or we can use a new guy. So connected to that, connected to this part. Okay, 3.03 milliamp. That is compared right. Then just move it a little bit, copy and paste. Again, like this. Oh no, yeah, just this one. Like that one. Okay, cool. 1 milliamp, 3.03 milliamp, and 4.03 milliamp. Everything works fine. Now I do have the next circuit, which is a parallel of R1 and R2. R1 should be 10K. So fortunately we had the 10K over here. I will talk about all of these connections, don't worry. So we had the 10K over here, and then we have our beloved 3.3K that we built over here. So as you can see over the circuit, we are talking about the parallel. The parallel means that our resistance 3.3 and 10K should have two common spots or two common points. The one leg of the 10K, as you can see using the jumper, is connected to one leg of 3.3K. At the same time, another leg of 10K should be connected to another leg of 3.3K. At the same time, we do have negative connection, which is connected to this point, is the common node of 3.3 and 10K. On another side, we do have the positive connection. Instead of connected directly to this part, I connect it over here, or I could connect it over here on the power tray and use a jumper in order to do that. So the jumper is going to be connected over here and everything is set right now. So the very first thing you have to do is just measuring, let's turn it off, measuring the total resistance. So the total resistance would be what? 1 over R1 plus 1 over R2, and then finding the reciprocal of that. First of all, we have to adjust it to read a normal resistance that we like. Each is something around 2.4K, so we expect 20K should be fine. So this is going to be the 20K. As you can see over here, this is a 20K. So again, get rid of the source. We don't need that right now. It means that we have to get rid of this part, or I just can simply disconnect that. And also this positive part, I can disconnect that. Cool, everything is fine. And right now, the only thing I have to do is just measure. So I have to connect it to both sides of the 10K or 3.3K, doesn't matter because both of them are connected. And I expect it to see 2.4K. So, I'm sorry, I should have my 2.47, which is which should be 2.48, but still acceptable. Then I have to find the current inside each branch. So that one is going to be a little bit challenging. Why? Because unlike the time that we only need the I total, obviously at the very first I can find the I total, then by finding the current goes over here, then adding it up over here, I can find everything that I need. So the very first thing we have to do, find the total current. Let's do it by connecting, as we all know. First of all, let's put it for the amp section, could be for the amperage, and we do have it as what? And we need some kind of expected to be around 4 milliamp. So we do have it as 20. At 20 right now, as you can see, it is 20. Then we have to do what? We have to connect our positive section, the positive part of the ammeter, to what? To our positive side of the source. These guys are going to be connected to each other. Then we do have this negative side, the negative side of the source, or the negative side of the ground, which is should be connected over here, and then we have to measure the current that goes through this point. By doing that, I can simply find the current that goes this way. Probably I can measure it as some kind of, let me fix everything. So it means that the positive goes over here. Okay. So the negative would be here. So let's just turn it on. And we have to read something around 4 milliamp. Oh, okay. Over here, here. Yes, 4 milliamp. 4.04, which is 4.03. Again, let me just show it to you, which is acceptable range. So right now we have to measure the what? Measure the current inside each branch. So at this point, we would like to measure the amount of current that goes inside the 10K. As you can see over here, by 10K, and if I would like to measure the current, I have to find the disconnection between the 10K and the part that it's inside this branch. Either I can have a disconnection between the top side over here and this kind of green wire, this is going to be connected to the main part, or I can have a disconnection on the bottom. As you guys just saw in the simulation itself, we are going to put our ammeter over here. So how we can do that? Again, we are going to put the ammeter on the 20 milliamp because probably based on our simulation, we do expect, based on the calculation, we expect something around 1 milliamp. So the way that we can do it, by the way, we don't have that much equipment. So I'm going to connect this guy like this, and then I'm going to connect it like that. So you can see it's something around, let me just light it up. So it is something around 1 milliamp. So everything is fine. Then it asks for the current that goes inside the 3.3K. So the very thing we have to do, we have to again just connect that circuit as the way it was, like this. Just connect this circuit. Okay, everything is fine right now, but make sure that your source should be disconnected. Then you have to have all of this connection related to measuring the current or voltage or ohm, whatever, and then just turn it back on. So right now I would like to measure the resistance that goes inside this circuit. Is that the case? So at this point I can have a disconnection, for example, between these two and these one, by connecting my ammeter between these two. I can for sure, as you can see, I just made a disconnection between these two wires because these two some kind of legs. Everything over here is making 3.3K. So by connecting my ammeter through those points, one would be like this and another one would be like that. Probably I should reach something around 3 milliamp. Yeah, as you can see, it's -3 because obviously I connected black side to this part. The red side should be connected to that part. And that's everything. It should be positive, by the way. So we had the currents. We had the total current. It was around 4 milliamp. We had 1 milliamp for the 10K, 3.3 for the bus for each of those, and we had the total of 2.4K. This question didn't ask for a voltage for each one. By the way, it is completely obvious. The voltage of this one, or the 10K, is connected directly to the source, so which is just again going to be 10 volts, and the voltage of these guys again are parallel with this one, so it should be 10 volts.